Hello, I'm Mr. Ibrahim Makoga from Educare TZ. I'm teaching physics. In our session now, we are proceeding with physics revision question about our topic that we have learned from the topic of Form 1 up to the topic of Form 4. All topics are present in our media. So you are welcome to subscribe, share with your friend, and comment in your media in order to improve more our lectures and our lessons. So I welcome you in the session. In this session, we are proceeding with revision topic of Form 1, and the topic is Archimedes principle and the law of flotation. We have already started. There are some videos for this session or for this topic. So you have to follow it in order to see the question that are solved that sessions, and we will proceed with this session to get more experience on how questions are constructed, So we are going to see the question number 3. This question states that a piece of glass weight in air 1.2 Newton and 0.7 Newton when completely immersed in water. Calculate its relative density and the density of glass. So here, this question need you to understand that the application of Archimedes principle and the law of flotation in determination of density and the relative density of substance. So you have given the little weight, the weight of object in air. Also, you have given the apparent weight. When object is immersed in fluid, if you weigh it, that weight we call it apparent weight, because there is a loss of weight when an object is immersed in a fluid. So you have to calculate relative density and density of glass by using this data of weight that you have given, this weight of the data that you have given. So let's see how the question can be solved. Yeah, as you said, you have given the weight of body in air. This is the little weight, is equal to 1.2 Newton. We have given the weight of body in water, apparent weight is equal to 0.7 Newton. We have given the density of water, 1,000, not 10,000, it is 1,000. Hapa ni elfu moja kilogram meter cubic. Yeah, and the relative density of glass is what you are required, and you are required also to determine the density of glass, So after having this data, we have to recall on which formula we have to use, in order to get the density and relative density of the glass. From knowledge of Archimedes principle and law of flotation, relative density is calculated by taking the ratio of little weight to up thrust. So if you take little weight, you divide by up thrust, you get relative density. So this is a formula to calculate relative density using the concept of Archimedes principle and law of flotation. We have given the little weight, but up thrust we have to calculate. We know that up thrust is the loss of weight. When an object is immersed in fluid. So that loss of weight is called the up thrust. So to get up thrust, take little weight minus the apparent weight. Little weight 1.2 minus apparent weight is 0.7. Here, if you minus, you get 0.5 Newton. If you make subtraction here, you get 0.5 Newton. So this will be the up thrust. All apparent loss in weight. That is about. So relative density is equal to real weight of earth then real weight is equal to 1.2 Newton over earth is equal to 0.5 Newton. If you calculate well, you get 2.4. You get 2.4. That is the relative density of glass. Relative density of glass is equal to 2.4. 2.4. That would be the relative density of the glass. And after getting relative density of glass, you can calculate the density of glass. Simple. By using the formula, relative density of substance is equal to density of substance over density of water. Yeah, density of substance over density of water. But we know density of water is 1 gram per centimeter cubic. 1 gram per centimeter cubic. So if you make the subject density of substance, we see that density of substance is equal to relative density times density of water. Relative density, density of substance is equal to relative density times density of water. So to get the density of glass, you have to take 2.4, which is relative density, times 1 gram per centimeter cubic. 1 gram per centimeter cubic. You will get the density of substance. That will be 2.4 gram per centimeter cubic. So it's a matter of changing the adding the SI unit here. 2.4 gram per centimeter cubic. That will be the density of the glass. Kwa hiyo kwa ni kawaida tu, so itakiwa ulisolve kwa namna kama hiyo. After then, let's see another question. Another question is here. In an experiment to determine the relative density of liquid, a solid Q weighted as follows. In experiment to determine the relative density of a liquid, a solid Q weighted as follows. Weight of solid Q in air, R is equal to 8.6 Newton. Also, we have given weight of solid Q in water. Apparent weight in water is equal to 6.0 Newton. And the weight of solid Q in liquid, IL, is equal to 5.4 Newton. These are the data that are obtained in the experiment to determine the relative density of a liquid. So we have to calculate. We have to calculate the relative density. We have to calculate the relative density of liquid. The relative density of liquid. But how we can calculate the relative density of liquid? There is a concept. By using the concept of Archimedes principle and law of flotation, there are principles, or there is a formula that is used to calculate that density of liquid. By using the concept of Archimedes principle and law of flotation, we say relative density is equal to weight of any volume of liquid over weight of same volume of water. Weight of any volume of liquid over weight of same volume of water. To determine the volume or the density of relative density of liquid, you take the weight of any volume of a given liquid over weight of the same volume of water. It means that if you take the volume of liquid be 20 centimeter cubic, you have to take also water 20 centimeter cubic and measure the weight of liquid and the weight of water. If you take the ratio of weight of liquid and weight of water, you will get the relative density. But by using to determine density of relative density of liquid, the good way that is used is by using a solid, by immersing a solid in both water and as a liquid. So the weight if you immerse a solid on water and on certain liquid, you'll see the amount of water displaced and the liquid displaced will be different. So by saying that to get relative density, you can take the weight displaced by solid on liquid divided by weight displaced the weight of water displaced by liquid by solid on water, kwamba utachukua lile jiwe ukiliweka kwenye liquid fulani, kwa mfano ethanol, utakuta displace ethanol volume fulani ambayo itakuwa ni tofauti na kwenye maji. Kwenye maji unaweza kukuta ika displace kiwango kikubwa au kidogo, lakini kwenye ethanol ika displace kiwango hivyo hivyo kikubwa zaidi kuliko kwenye maji au kidogo zaidi kuliko kwenye maji. So that is about. And we know that weight of liquid displaced, is equal to upthrust. Weight of fluid displaced, we know it is upthrust. So here generally you can say that relative density is equal to upthrust in liquid over upthrust in water. Upthrust in liquid over upthrust in water, you get the relative density of substance. If you take upthrust in liquid over upthrust in water, you'll get the relative density of liquid. So let's take this make this UL. Make UL upthrust in liquid be the weight of object in air minus weight of object in liquid UL. And the UW upthrust in water be the weight of object in air minus the weight of object in water. Then after that, you see, relative density is equal to upthrust on liquid over upthrust on water are this UL over UW. UL is given by taking the little weight of object minus the weight of the object in liquid. But UW take the little weight minus the apparent weight of object in water. Then this. So UL is equal to R, this is the little weight minus apparent weight in liquid, and this R minus apparent weight in water. This is about upthrust in water. So this sign UL represent upthrust on liquid, UW upthrust in water, AL apparent weight on liquid, AW apparent weight on water, and that R represent real weight. After getting this, it is a matter of substituting. Kwa hiyo baada hapa unaenda tu una substitute value zako, una substitute value kuja kupata relative density. So you see weight of body in air is equal to L, weight of body Q in water is equal to AW, weight of body Q in liquid is equal to this. Tumepewa. Then go to our formula. A formula. Relative density is equal to little weight minus AL. Little weight is equal to 8.6 minus apparent weight in liquid is equal to 5.4 we have given. Little weight is equal to 8.6 and apparent weight in water is equal to 6.0. Is this, if you subtract, you get 3.2, and down there if you subtract, you get 2.6. If you divide this, we get 1.2. Get 1.2. Then relative density of a liquid is 1.2. Is 1.2. That is about the relative density of liquid. So this is how you can calculate the relative density of liquid if you have given the weight, the apparent weight and little weight of a solid. So this is a simple way to determine the relative density of liquid. So after then, let's continue with another question. The question first states that state the law of flotation. After stating the law of flotation, B, why piece of iron sink in water while a ship made of steel floats? Give the little reason. Ni kwa nini ya kwamba kipande cha chuma kinazama. Lakini meli ambayo imetengenezwa na vyuma vingi, imetengenezwa na mkusanyiko wa vyuma vingi, yenyewe haizami. Why? Unajua steel ina density kubwa, lakini meli inatengenezwa na steel kwa wingi, lakini haizami. Elezea ni kwa nini haizami. Kwa nini zingine zinazama lakini yenyewe haizami? And I'll start by giving 3 reasons. C. When a wooden block floats in water, it displaced 0.06 meter cubic of the water. Find the weight of the wooden block when it is in air. When it is in air. Kwamba umepewa wooden block. Wooden block ilikuwa inaelea kwenye maji. Ilivyokuwa inaelea kwenye maji, ikadisplace maji kwa volume hapa ya 0.06 meter cubic. Anakwambia kwamba tafuta weight ya hiyo wooden block ikiwa kwenye air. Maana utafute real weight. Find real weight. How to find real weight? Use the law. So you have to state a law, but you have to know how to apply. Ujue namna gani ya kuistate law, lakini ujue namna gani pia ya kuiapply hiyo law. Kwa sababu kama hapa tayari hii hapa law inakuja kuapply hapa. Hii law itakuja kuapply hapa. Law flotation. Kuja kupata weight hapa, lazima unajua hapa condition. Hii law ina state vipi? Ukishajua hapa unakuja kuweza kusolve hapa. Ukishindwa kuistate law ukasolve hapa, it means ni kama mtu ulikalili ila haukuelewa, au umestate law umeshindwa kuapply hapa, pia na wewe uliclaim law kwamba wakiuliza state Archimedes law inasema, Archimedes principle inasema hivi, lakini hujui namna gani itakuja kuwa applied. The law of flotation states that a floating body displaces its own weight of the fluid in which it floats. In which it floats, not it float, it floats. A floating body displaces its own weight on a fluid it floats. It means that when a body is immersed on a fluid, it tends to displace amount of water that are equal in weight with the object. Ya kwamba hilo inamaanisha kwamba object yote ikizamishwa kwenye maji itachukua nafasi ya maji ambayo yale maji yana weight sawa na yenye object. It means that weight of the water displaced, weight of liquid displaced is equal to the weight of the object. Will be equal to the weight of the object. That is the meaning of the law. We see how to apply. And B, why a ship does not sink? A ship does not sink in water because it contains large hollow space. It contains large hollow space first. This space helped what? Large volume allowed the ship to displace large volume of water, leading to a greater upthrust. First, it has the large hollow space. It means it contains air to make it able to float. Also, it have a large volume. It tends to displace large amount of water that will provide upthrust to help the ship to float. Kwa hiyo inachukua volume kubwa sana ambayo itaifanya ile meli iweze kuelea. Yaani yale maji yawe mengi yaweze kuisupport meli ufanyaje kuelea. Hiyo ni mojawapo sababu kwa nini meli inaelea lakini kipande cha chuma kielea, lakini hicho kinatengeneza meli. Also, furthermore, the hollow space makes the average density of the ship to be less than the density of the sea water. Pia ile hollow space iliyopo pale inaifanya meli density yake, average density yake iwe ni ndogo kuliko density ya yale maji ambamo imo. So that is about. After then, let's see part C of the question, how to solve. We have given the volume of water displaced is equal to 0.06. I have not written here, so it is 0.006 meter cubic, and weight of block in air is what we are required. From law of flotation, weight of object is equal to weight of displaced fluid. Then weight of water is equal to mg. But you have given not mass, we have given volume. Mass is equal to density times volume. Here, substitute. After then, enter the data. Density is 1000 kilogram per meter cubic. Volume is equal to 0.06 meter cubic times 10 Newton per kilogram. You will get weight of water is equal to 60 Newton. Since the weight of water displaced is equal to the weight of the object, hence the weight of the block will be equal to 60 Newton. Will be equal to 60 Newton. Something to consider here: why I used this volume here for water. You see, the volume of object will be the same as volume of water displaced. So the volume of water displaced is here. To get the weight of water displaced, use the volume and the density and the gravitational acceleration. You get this. So this was how supposed to be answered. This law of flotation have to be applied here to solve. Simple and clear. By saying that, my lovely student, this marked the end of our session. Thank you very much for watching Educate Z. Don't forget to subscribe, share, and comment in our medium. Have a nice moment.